Okay, today we are working on graphing systems of equations. We are going to be learning how to determine the number of solutions that a system of equations might have, and we are going to be solving them by graphing. So we're going to go ahead and get started with this. First thing, let's talk about our different types of solutions. We can have exactly one solution, we can have infinite solutions, or we can have no solutions. And exactly one, what we call that in Algebra 1 is we call it consistent and independent. And what the graph would look like for that, let me go ahead and draw my graph. This is what you should be drawing too. So here's your y-axis and your x-axis. And you would have a graph of one line and then another line. And notice that they intersect at one point. So if they have exactly one solution, we call that consistent and independent. Now, consistent and dependent is whenever you graph, there's the x-axis, here's the y-axis. So it's whenever you graph one line, so let's say there's our line, and then you graph another line, and it's the same exact line. So that we call it's infinite solutions, and we say that that's consistent and dependent. And then the other type that we have is no solution, and we call that one inconsistent. And inconsistent would be whenever you've got one line and then the other line is parallel to that, so they will never intersect. So they will never have a solution, and so that one is called inconsistent. So those are our three types of solutions that we need to know. And yes, you do need to know the terminology for those. So the terminology is very important. Not only these, the exactly one solution, the infinite solution, and no solution, but you also have to memorize consistent and independent, consistent and dependent for infinite, and inconsistent for no solution. All right, so now let's go ahead and start solving these. So the first thing you want to make sure is you want to make sure that they are in slope-intercept form. So we look at these two equations and we see that they are in slope-intercept form. Okay, so we would go ahead and draw your graph. Remember, you only need one graph for each problem. Okay, so now let's look at this first equation. We see that the slope is -3, and we can say that's -3/1, and the y-intercept is 10. So that means I need to go all the way up to 10. I hope I drew this big enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be all the way up here. And then our slope is -3, so that means I go down 3, 1, 2, 3, and over to the right. Down 3, and over to the right 1, down 3, to the right 1, and keep going, whoops, not there, and extend it all the way throughout your graph. So I'm going to go ahead and connect those dots. And now let's go ahead and do the other one. The other one, notice here, the slope is 1. It's the number in front of the x, and the y-intercept is -2. So we start on the y-axis at -2, and we go up 1 over to the right. And we see that we have intersected here. Intersected with the other line. And so our solution is where it intersects, right there. So that solution is a positive 3, because it's 1, 2, it's over 3. Our x is 3, and our y is 1. So there is our solution. And for this one, we say that this is consistent and it is independent. That's spelled wrong. Independent. Okay, and the reason why is because it has one solution. Okay, let's look at example 2. Example 2, we're solving these two equations by graphing, and first thing that we notice is that the equations are not in slope-intercept form. So we're going to take this 2x minus y equals negative 1. We're going to put it in slope-intercept form. First thing is subtract 2x. That gives us negative y equals negative 2x minus 1. And then we need to divide everything by negative 1. And that gives us y equals a positive 2x plus 1. So now let's look at the other equation. We've got 4x minus 2y equals 6. We're going to subtract 4x from both sides. That gives us negative 2y equals negative 4x plus 6. We need to divide everything by negative 2. So the negative 2's cancel out. That gives us y equals a positive 2x minus 3. All right, and then you would go ahead and start graphing these. Okay, so our y-intercept on the first one is a positive 1. Our slope is 2, or we could say 2 over 1, so we go up 2 over 1. And the opposite of that is down 2 and to the left 1. And you go ahead and connect those points. The next one, our y-intercept is negative 3, so we start on the y-axis at negative 3. And once again, our slope is up 2 over 1. Now remember, if we have same slope and different y-intercepts, our lines are said to be parallel. So notice these lines are parallel, therefore they will never intersect. And if they will never intersect, our answer is no solution. And what's the terminology that we use for no solution? That is inconsistent. Inconsistent. All right, example 3. First thing we notice is that our equations are not in slope-intercept form. So let's take that first one, x minus y equals 2. And let's go ahead and subtract x on both sides. That gives us negative y equals negative x plus 2. Divide everything by negative 1. And that gives us y equals a positive x minus 2. So now with the other equation, we've got 3y plus 2x equals 9. This isn't even in standard form. Make sure you're getting the y by itself. We're going to subtract 2x on both sides. That gives us 3y equals negative 2x plus 9. Divide everything by 3. And we get y equals negative 2/3 x plus 3. And then we'll go ahead and graph those. So go ahead and draw your coordinate plane. With the first line, I see that the y-intercept is -2. Our slope is 1 because that's the number in front of the x. So we go up 1 over 1 to the right. The opposite of that is down and to the left. Connect those points. And there's the first line. The second line, we've got a y-intercept of +3. And our slope here is -2/3. So we go down 2 to the right 3. And there we have just hit the other line. All right, connect those. And we see that our solution is 3,1. And the terminology for that is consistent and independent. All right, so I'm going to pause the notes here for now, but there are more examples, so don't go away. Okay, example 4. So we're going to solve these two equations. First, we've got our first equation, and it is already in slope-intercept form. So that's y equals -2x minus 3. Then the other equation is not in slope-intercept form. So we've got 6x plus 3y equals -9. So let's go ahead and get that y by itself. So we subtract 6x from both sides. It gives us 3y equals -6x minus 9. Divide by 3. And we've got y equals -2x minus 3. Now, looking at our previous equation, I see that they are the same. So you don't necessarily have to graph them because you see that they're the same. You know that your answer is going to be infinite solutions. They are the exact same line. And with infinite solutions, we've got consistent and dependent. Okay, so but if you'd like to, you definitely could graph and see that those are the same lines. So if you have any questions, please ask me in class. Thank you. That was the last example.